Hey there, this is Angie with Angie's Beyond the Lecture. Good morning. Thank you for joining me. Today's video is going to cover ionic compounds with the transition elements. So a few days ago, or actually I think yesterday, I put out a video on how to name ionic compounds, but I left out the transition elements because they're a little bit different. They have a little bit of a twist there. So first things first, and before I dig in, go ahead and hit like and subscribe if you'd like to be notified when new videos roll out on my channel. I'd appreciate it. All right, so we do have our transition elements. They're considered to be in the D block. And the D block, I'm feeling green today. Okay, and we do have these included as well. Our main suspects are going to be, so luckily, when we're talking about transition elements and naming and the system we use for naming, there are only maybe a half a dozen metals that come into play here. Yes, anything's fair game, but I'm just going to highlight or circle the common ones that you'll see. Chromium, actually just let me take my pen. All right, so we'll look at chromium. Gosh, that almost blends in. Okay, chromium, manganese, iron, cobalt, copper. Gosh, those are the main ones. You'll also see zinc and mercury, and I'll talk about those real quick when we go back to the review sheet. And quick reminder too, this review worksheet or review outline is out of my website. Just go ahead. I'll link it in the video description and you can go out and print it out and follow along with me or simply just review it later, whatever you want. It's yours to have. So again, we've talked about the D block where the transition elements are. And these particular metals, they can basically give away different numbers of ions, or sorry, not ions, electrons to form different ions, okay? So copper, and again, these are the main, the primary suspects here in our transition element ventures. So we have copper 1 or copper 2. So the Roman numeral that we give here simply designates the charge that it carries. So what we're saying in copper is that we can lose 1 electron to have a positive 1 charge, or we can lose 2 electrons to have a positive 2 charge. All right. And the same goes down the line for iron. We can be +2 or +3. We can be +2 or +4 on lead, +2 and +4 on tin. And cobalt, we can have +2 or +3. So yes, it's just another thing to sort of memorize in the mix. But when you work with it a lot, it'll become nearly second nature. Like zinc, and also zinc, that actually carries a +2 charge, and we typically don't designate Roman numeral 2 when we talk about zinc. We typically assume that it's +2. All right, so do be aware of that. And I do have some examples here. I'll go through, let's see, I think we have like 4 or 5. Yeah, we have at least 4 or 5. I'm going to write, add some writing here on a couple of these just so you can follow along. So again, copper can be +1 or +2. And we know chlorine is group 7, so that's a 1, -1 charge. We can actually, we don't need a crisscross, do we? We don't need a crisscross because we have a +1 and a -1. So we can just say that it's CuCl. Now, when we have copper 2, that's where we need to change things up a bit. And if we crisscross, we'll have 1 and 2. So again, 1 copper for every 2 chloride ions. All right, so we still employ tactics to balance the charges, based on what we're given for the metal. And notice the non-metal is static. So chlorine's always going to have a -1, right? We're just going to adjust the anions based on what we're given for the metal cation. All right. Chlorine matching with iron, that's example, another example here. Yeah. So we have iron matching with chloride, or sorry, iron 2 matching with chloride and iron 3 matching with chloride. All right. So we're just going to adjust the number of chlorines that are going to be matched with it. And then we have lead 2 and lead 4 oxide. So I wanted to look at the second one real quick. So if we're given lead, okay, and we crisscross. So notice we have 4 and 2, 4 and 2 to overall net charge of positive 2, right? We need to crisscross our subscripts or manage those so it evens out to be an overall 0 charge. And we end up with Pb2O4. And it is appropriate. Notice we have 1 lead and 2 oxygens in our answer here. So we could reduce this to PbO2 simply because, if we divide both numbers by 2, we'd end up with 1 and we'd also end up with 2 as well. Let me demonstrate that down here. So Pb2O4. So if we divide by 2, ends up being 1, 2. All right. So we're basically just reducing it. So it doesn't happen often, but it can happen in certain circumstances where, depending on what you're matching up with your metal and non-metal. So some additional examples down here I put up. Now 10 can be, we're looking at example 2 under number 4. 10 can have a charge of 4 and 2 as well. So notice that, I'm going to change up the color here. Just look at this. SN. We have the same situation where if we crisscross our subscripts, but that's not the final answer, right? We end up with 110 and 2 sulfurs. So divide by 2, SnS2 for that. Now we have a special case here. There's always a special case, every category, right? No matter what. I look at exceptions. So we do have these 2 special, we have H2 2+, or sorry, Hg₂ 2+, and simply Hg₂+, okay? And we give, but notice we give the first one Mercury I, and this, sorry, didn't mean to hit the microphone, and the second one Mercury II. So we have this diatomic ion going on here. So what is that? So di means 2, right, in Latin. It just means that Mercury can exist as a pair in this particular case. I'm not exactly sure the reason why. Mercury is a liquid, right? It's one of the, actually probably the only metal that's a liquid at room temperature. But nonetheless, we just have to know that there is a Mercury I and a Mercury II. And notice the configuration's a little bit different. So I noticed that you see Hg₂. I'm going to write these off to the side here. Okay, so I think students tend to confuse that they see this 2 here attached to the first one here. They see a 2. All right, I'm just gonna arrow that over, and they assume that is Mercury II, right? No, it's Mercury I. So think of it as having each Mercury there. Each Mercury has a +1 charge to combine to be a +2. You can almost look at it like this. I'll do maybe a little bit better scenario here. Take that here. Think of it as Hg +1, Hg +1, and we'll net an overall 2+. Okay, and that's where we get the 1. That's how I look at it. So just know it's kind of a trick question. I see it come up on quizzes and tests and things like that. It's an exception. Be very, very wary. They just might give you maybe a compound and say, they might just have you name it, right? Or they might say, you know, which mercury are we talking about here? We talk about one or two. And of course, they give an example here, Hg₂, Cl2, and then we have HgCl2. So notice our Cl2s are the same, but in one case we have two mercuries, in the other case we have one. So, and just know it again, it's a special case, and that we can combine two plus one mercuries to get a plus two on the top example, and then we can just have one mercury to have a plus two charge. There you go. All right, so you always check the charge of the transition metal to determine the Roman numeral. So yeah, when you're going backwards. So we'll do a couple of examples here. So say like we're doing cobalt. Right. So we'll do cobalt chloride, right? And so we need to determine what charge we have here. That's the big question, right? And so we'll recognize, okay, cobalt's a transition element. I need to add a Roman numeral. I can't assume it's 2 or 3. So I'll just make sure, okay, well, chlorine is -1, and we have 2 of them. So we're going to carry a -2 charge here. So we have to have a +2 to balance that out. So we'll have CO or Ca, cobalt chloride. All right. We could also have a transition element with, say, a polyatomic ion. So we know sulfur is, or sorry, not sulfur, sulfate is -2. So we would need to know right away that has to be a +2 to match that. And there you have it. So there's formula to name. And then I've also gone over name to formula. I hope you found this video helpful. I'll go ahead and link the ionic compound naming just so you can get an overview. If you haven't seen that yet, you might find that useful as well. So thanks again for watching. Have a great day.